Case number 22. We are going to verify this given identity. Secant squared x plus cosecant squared x is equal to secant squared x times cosecant squared x. In short, the sum of secant squared x and cosecant squared x is just equal to their product. In order for us to verify this, we need to remind ourselves of the transformation of secant x and cosecant x in terms of sign. Cosine are combination of both, and the inclusion of the Pythagorean identities. We are going to manipulate the left-hand side for this matter. So we are going to start with secant squared x. We know that secant squared x is the reciprocal of cosine squared x, or the secant x is the reciprocal of cosine x, and since it has a degree of 2, we can write it here 1 over cosine squared of x. That's for the first term. We're going to manipulate this left hand side and find out if we could process this and return to the value or the identity that can be found on the right hand side. Now, as for cosecant squared x, it's also the reciprocal of sine squared x. So we have here plus 1 over sine squared x. Okay, so this is its next version. Again, our goal is to come up with an expression that will be equal to the product of secant squared x and cosecant squared x. What we need to do here is to come up with the least common denominator to combine these two fractions or rational expressions. The LCD here is the product of the denominators. So we'll have here the product of the denominators is simply cosine squared x, and you have here sine squared x. Just like if you have 1/2 plus 1/3, your LCD is 6. That's the product of 2 and 3. Now, we are going to come up with equivalent fractions or rational expressions for the numerator. So this expression, cosine squared x and times sine squared x divided by cosine squared x, we only have this remaining because the cosine squared x will be removed. So again, cosine squared x times sine squared x to be divided with this denominator. What remains is sine squared x times 1. So you have here sine squared x. That's for the first. Of course, if you're not convinced, you can simply simplify this. You have sine squared x here. You'll just return to 1 over cosine squared x, your original first rational expression. Next, for the second rational expression, this entire expression to be divided with sine squared x. This will be removed, leaving cosine squared x to be multiplied with 1. So you have here cosine squared x, and of course the operation is plus here. Next step here is to remind ourselves that the entire numerator, the sum of sine squared x and cosine squared x, is one of the 3 Pythagorean identities. This is just equal to 1. That follows the idea of a unit circle, and this is the first Pythagorean identity. That would mean we can simply write it as 1 over, you have here cosine squared x, and then sine squared x. We are now closer to giving or finding an identity which is just the product of secant squared x and cosecant squared x, because you can just simply separate this into 2 different fractions. You have 1 over, you have here cosine squared x times 1 over sine squared x. It's just a product of 2 different rational expressions. And with this, 1 over cosine squared x is simply secant squared x, and you have here 1 over sine squared x is cosecant squared x. In short, we have verified that the given identity on the left hand side is just the same as the identity on the right hand side from this given case. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.